Okay, next thing I want to talk about when we're doing this formal logic stuff is that every statement must be, if it's complex, must be dyadic. Because we have this notion in logic and mathematics that when we have formulae or we're doing particular kinds of, I keep using the word rendering, but there we go, renderings of things, it's best to put it, and you should put it, there's even a moral imperative there, in the simplest way possible. Now, dyadic is a term, literally, it just means two-ish. That's it, two-ish, dyadic. Now, what does it mean for a statement to be dyadic? It has two parts. What two parts? Basically, we can say it has a, the technical words here would be, it has a sinistral dyad and a dextral dyad. There's a technical term. What do they mean? Left, right. So every compound, I'll say this, most compound statements are going to be dyadic. That means they have a left side and a right side. Negations are a little bit of a weird category where that doesn't work exactly. But, nevertheless, what does that mean? Well, consider this. Like, if I say something like A and B, this is dyadic. Look, it's got a left side, it's got a right side. If I just say A and, that's not dyadic. There's no right side to it. Okay, so it's missing something. It's not, the word we would say here is this is not a WFF. What does that mean? Well-formed formula. It's not, there's something wrong in the way in which it's been rendered. Now, furthermore, in order for something to be well-formed, it needs to be put in the simplest way possible and a simple, correct way. So, consider something like this. If I say this, A and B and C. Is this dyadic? It's got a left side, a right side, it's got a middle too. This is not a dyadic statement. Yeah, it's not inconceivable. We can make conjunctions in three components. That's fine. Today's Wednesday and I'm going to the movies and I'm having a good day. Nothing outrageous about that. But rendered formally, this is not well formed because it's not dyadic. It doesn't fit that two-ish quality. It doesn't have a left side and a right side. Now, if it's all conjunctions, what we need to do is we need to make it so we have a left side and a right side. And if it's all conjunctions, what we can do is we can put parentheses around some parts of it that will make it dextral and sinistral and give us our dyadic component. So with this one, all ands, I can stick parentheses there. Now it has a big left and a tiny right. Instead, when it's all conjunctions, I could put the parentheses around this side. Now I've got a big right and a little left. That's fine. But for formal logic, this is well formed. It has a left and a right. It has a left and a right. And then we can, anytime when we've got parentheses, we can look inside it and say, is that dyadic as well? Now, if it's all conjunctions, it doesn't matter where you put the parentheses. Same thing with disjunctions, whether inclusive or exclusive. If I've got all A or B or C, I can put the parentheses here. That's totally fine. If we put the parentheses around here, that's totally fine. These are dyadic statements, and they are well formed. That putting the parentheses wherever you want, as long as it gives you a left and right, especially in translations, that works with conjunctions and disjunctions. Does not work with anything else. So, if I say something like this, A arrow B arrow C. Well, first of all, is that dyadic? Nope. Now that's like the others. Now, I could do this, or I could put it this way. Now, both of these are dyadic. However, unlike the conjunction and disjunction examples, these two things mean entirely different things. entirely different things. In fact, if I were to read them back to you, I'd have to read them back a little bit differently. So when I was doing this, like this one, A and B and C, if I read this back, this would be A and B and C. If I read this one back, A and B and C, there's no change in me reading it back because they're identical. They have the same semantic scope, which is the way of saying it. They're saying the same thing. These two things, just for the ease of reference in our lowest level board, we'll call them Formula 1 and Formula 2, just for labeling. This one right here says this: if A, then B. If all of that, then C. Is that the same thing as this? If A, then, if B, then C. I'll say it again. This one says, if A, then B. If all of that, then C. Whereas this one says, if A, then if B, then C. Those two things are not equivalent. I even have to say it back in English differently because these two things mean something entirely different. So one thing we're going to want to look out for, and I'm going to go into more detail. So if you're already looking at this going, I have no idea how to distinguish between these two things. We're going to go into more detail about that as I get into talking about conditional statements. I just simply wanted to say at this point that parentheses, if they're involved with conjunctions and disjunctions, they're going to be a breeze. Parentheses with conditional statements are a bit more of a challenging endeavor because you can make a lot of mistakes here that I don't want you to make. But I'm going to explain how not to make those mistakes in the next video when we start talking about conditionals more properly.